Hello. In this video, I'm going to explain problem 25 from the 2014 F equals MA contest. In this problem, we have a block with mass m released from rest at the top of a frictionless ramp from a height of h1, and ultimately the block will slide down and then go up a second ramp with the same angle of inclination, theta, except the second ramp has a coefficient of friction mu k, or coefficient of kinetic friction, and we're asked to find the new height, h2, that the block reaches on the second ramp. So, the key, as you will see, is the conservation of energy. The difference in height, that is, the reason it won't make it back up to the same height, h1, is due to energy being dissipated by friction. In the absence of friction, it would make it back up to exactly the same height, and friction is the only thing that makes this difference. So let's look at our setup. The total energy is just the potential energy from sliding down the first, or at the beginning, when the block is at a height h1, which means that it's equal to m times g times h1. Now, that is going to equal the energy at the end, which will be mgh2, plus whatever energy is dissipated by friction, which I'll label E thermal. Since the energy that's dissipated by friction basically goes into random particle motion, which is basically thermal energy. So how do we calculate the thermal energy? That will be, so when the block starts sliding up the second ramp, we have an angle of inclination theta. Gravity is going to exert a force inward of mg, sorry, that's a little m, mg cosine theta. It's going to exert a force parallel of mg sine theta. These are the two components of gravity. And then the normal force has to balance mg cosine theta so the block doesn't fall through the ramp. And now the frictional force, sorry, this diagram is getting a little cluttered, will be the frictional force Ff will be mu k times n. That's how it will be mu k mg cosine theta. Now, what is E thermal? Well, E thermal is going to be the force that friction exerts multiplied by the distance that the block slides, some distance d. Now, what is the force of friction? Well, it's mu kn, so it's mu k mg cosine theta, multiplied by d. And what is d? Well, the height that it reaches is h2, and so d is the distance along the ramp. Well, h2 is equal to d sine theta, and so d will actually equal h2 over sine theta. And so okay, so let us go to the a new page. We had mg h1 equals mg h2 plus mu k mg cosine theta times d over sine, sorry, times h over sine theta, or h2. And so we can remove all these mg's, and so we get h2 times 1 plus mu k cotangent theta is equal to h1, and therefore h2 is equal to h1 over 1 plus mu k cotangent theta. Now going back to the options, we see that everything is written in terms of sines and cosines. So no matter, we can just multiply numerator and denominator by sine theta. It'll give us h1 sine theta over mu k cosine theta plus sine theta. Now, one thing that would be good to do is a quick common sense check, which is that if mu k is equal to 0, so if there's no friction, then h2 should equal h1. And so the part of the denominator that does not have any mu k in it should balance the numerator, so you would get just h1, and indeed we see that is the case. So at least our answer here passes at least this quick common sense check. So we can have greater confidence in our answer. So now, h1 sine theta over mu k cosine theta plus sine theta tells us that the answer is A. Alright, and that concludes this problem. I hope that was helpful. Thank you for watching.